For the problem at the top of page 12 in your note packet, you're asked to find an exponential function of the form y equals, or f of x equals ca to the x power that contains these 2 points. So if we take a look at the points, the point 0, 3 is the y-intercept, and that's your initial point. And then the other point, 275, is another point that happens to be on this function that you're trying to find. Our goal is to find a value of c and a value of a to define this function. So to start out with, remember the value c is our initial value. So I'm just going to rewrite this as y equals, and then our initial value of 3, a to the x. So this value here is our c value. Next we need to find a. And to do that, we're going to plug in the next point, which is our xy value here. So for y, I'm going to plug in 75 equals 3a, and then the x is 2. So our goal is now to find a. So to get a by itself, I need to get rid of the 3 first. It's hooked by multiplication, so to undo multiplication, we divide. So I have a squared is equal to 25. To undo a power, I take a root to both sides. So I'm going to do the square root to both sides. Now normally we would put in a plus or minus symbol because there are 2 values that would work for a. But in this instance, when we're talking about the base of an exponent, our base has got to be a positive number. So we're not going to have a plus or minus here. It's just going to be a positive 5 is equal to a. So our equation, going back to our function f of x equals, our c value was 3 times, and then 5 to the x power. Now, a mistake often made is, I can multiply 3 times 5 together, but that's not just 3 times 5, that's 3 times 5 to the x. And order of operations says that you have to do the power before you do multiplication. Since I don't know what that value of x is, I'm not going to get to do the multiplication. This would be your final answer. For the problems down below, we're going to use something called a change of base formula. That allows us to compute a logarithm that's not base 10 or base e, the natural log function, because those we can use on our calculator. If it's another base, we may not be able to use our calculator so easily. So for example, log base 5 of 25. I can think about that and come up with the answer for that, because remember, this is looking for the power that you would take 5 to give you the answer of 25, or 5 to what power gives me 25. And the value of that x would have to be 2. We can kind of do that by inspection. So I should come up with an answer of 2. But using the change of base formula, I can use my calculator to help me out. I can rewrite this as the natural log of the argument, 25, over the natural log of the base, which is 5. And if I use my calculator, the natural log, let me pull this down a little bit here, the natural log of 25, close parenthesis, divided by the natural log of 5, close parenthesis, and the answer is 2. Right? Or, I could put the number 2 here, that's exactly equal to 2. Or I can use log base 10. So I can do log base 10 of 25 over log base 10 of 5. Remember, I don't have to write in the base 10 because that's common logarithm. So if I take my calculator once again, and now use the LOG, log base 10 of 25, divided by log base 10 of 5. I end up with 2 as well. Now, for this problem, that wasn't all that exciting, but if I have a different logarithm that I don't know what the value is by inspection, for example, if I have, what's log base 5 of, I don't know, 37 equal to. All right, well, I could try 5 to the x equals 37, but I don't know exactly what that power would be. But now I can go ahead and do a rewrite by using either the natural log over the natural log or the common log over the common log. So if I rewrite this by changing its base, I'm just going to do natural log 37 divided by natural log of 5. That'll get me a decimal approximation that'll work for this. So let's see. Natural log 37 divide natural log 5. And it's going to be about 2.24. So if I took 5 and raised it to the 2.24 power, it should get me something pretty close to the number 37, or that's what log base 5 of 37 is equal to, about 2.24.